Welcome back. Finally, we start building some gameplay. It's not a fast process. Until all the pieces fall together, it will take some development. But once that happens, we will have our game. Let's create gameplay level by making basic level. Now we need to save it. Name it Tile Flipper. This is where our gameplay action will happen. So when we hit play, this level will use the set game mode. We have none in our project settings and none set in the game mode override option. You see me using multiple content browsers. You can add one by right-clicking on the content browser, selecting Add New, and then dragging it to set it in the desired position in the editor. Now go to our Blueprint folder and create Core Gameplay folder. Here we will be adding classes related to our gameplay. Now go to our parent classes, as we need to create new child classes for our Tile Flipper game level. Use BP_TF prefix for those classes to know that those are part of our Tile Flipper gameplay. Move newly created children classes to our Core Gameplay folder. Do same for controller, naming it BP_TF_player controller. Do same for player state. This time we start using it to store player data. Now we can set our game mode for our Tile Flipper level. Also set our player controller and player state. We will definitely utilize the game state class, so we need to create a custom one and set it. Make sure to create game state, not game state base class, as we using game mode, not game mode base. Name it in our usual naming, BP_TF_game state. And set it in our level game mode. Make sure to save all. Now this level will be our gameplay level, and we can playtest it in editor. So what do we need now that we're building tile flipping gameplay? Well, first of all, we need our tile. Add actor class. We will use it to create our tile that we can spawn to our level. Name it BP_tile. We can't rename default scene. So first add cube to our scene. Now drag cube to replace default scene root and add new scene. Name new scene rotate. Drag to replace tile as root of our tile actor. Change back rotate transform to 1. Now we have our tile that we will use to make grid. Now how do we make grid? Do we put manual work and place each manually? Of course no. We will make grid spawner actor to do it for us. Add one more actor class and name it game manager. For now, it will just spawn the grid, but who knows what we might add later. Now, we need to drag this actor into our level, as this will be the location point in the world that we use to spawn our grid. We can delete those events. We will make our own named spawn tile grid. So how do we want to initiate this spawn tile grid event? Well, this is our gameplay feature, so we probably wanted to spawn from our game mode. Since the game mode exists only on the server, any event called from it, unless defined differently, will run only on the server, which is what we need. And we will be able to control when we want to spawn it. For now, we just need it to happen. Let's just do it on begin play of our game mode. We will develop step by step. Later, we can move it to when both players join the game. For now, we just want to create a functioning tile grid. To call the Game Master event, we first need to get the actor of the class, as the Game Master is part of the level. We will get a reference to it using this function. Promote it to a variable as we might need it later. Now let's get into the habit of adding variables to categories, as we will soon have a lot of various variables, and we need to keep them organized. From the Game Master, since it's a hard reference, we can call the actor event directly. I might make a separate video on the difference between hard and soft references. A hard reference provides direct access to a class's events, but creates a dependency. I wanted to hit play, but we did not add any logic for spawn tile grid, so let's do that. Well, to spawn something, we use spawn actor from class function node. For a class to spawn, we set our BP_tile. Split the transform input. A transform is made up of location, rotation, and scale. These values determine where our tile spawns, as well as its rotation and scale. So we wanted to spawn where our Game Master actor is, so we get its location with getActorLocation function. Let's connect it to spawn location. It did spawn, but inside the ground. Go to the tile and set its z-axis to 50, as we are below our scene root. The tile is 100 centimeters tall, so that puts it 50 centimeters above the ground. Now it's perfect, and tile is exactly as big as our character. We're building a multiplayer game, so let's see how it behaves with multiple clients. To do that, set the number of players to 2, set the net mode to play as listen server, and hit play. It did spawn for our server, as you recall, because the event to spawn the tile grid was run by the game mode. So, we see it with our server client, also known as the host, but not with the other client, who is just a regular client. For the tile to spawn on the client, we need to set our tile to be replicated. Tick Replicate and Replicate Movement. Now our tile is replicated to the client. Great! We'll return later to test how our tile grid behaves. For now, let's create the tile grid properly. So let's finally start creating our tile grid. How will we do it? Well, we need to spawn multiple tiles, and for that, we will use a for loop node. This engine macro loops a set number of times from the specified start index to the last index inclusive. Set last index to 4. This will spawn 5 tiles. It did spawn 5 tiles, but they all spawned in the same place. We need to modify our loop so that the tiles spawn in a line from one another. Drag from spawn location and make vector. This just splits location to 3 vectors. Also split location of our Game Master. We can just connect X vector, as we won't need to adjust it. X vector is red one here for our Game Master, and will be same for all tiles. Y and Z are the axes we want to modify to create our grid. To move each tile to the right, we need to add the loop index multiplied by the distance we want to use between each tile to the y-axis. We can drag from input and create multiplication node. We need to multiply the index by the value we want to set for the distance between each spawn tile. It worked, but they all spawned at the exact width of each other. They all are 100 centimeters squares, so add a bit to make a spacing between them. To recap, we do a loop that spawns 5 tiles, and for each tile, we add the index of the loop multiplied by our set distance value to the game master's location and set as location of new spawn tile. So the first tile is at the original game master location. Second one is plus 110 centimeters on the y-axis. The third tile is at plus 220 centimeters, and so on, until we reach the last one at plus 550 centimeters. Now let's promote this hard-coded value to a variable, so we can modify it from other classes. Name it distance. Add it to grid setup category. Also, let's promote the last index to a variable, so we can set the grid size. Select Spawn Tile Grind Event and add inputs for our variables. Add grid size integer input. Drag our grid size variable and create a set node. It will do this automatically if you drag it directly onto the pin. Add one more input for our distance float. Add set node for our distance variable. Now our event uses those variables to spawn the modified grid. Let's add comments before it gets lost in the blueprint noodles. Commenting parts of the blueprint code can make it easier to read as our code grows. Now if we hit play, we're back at square one because we call our spawn event in the game mode, and it has 0 default values for the inputs. Now we can modify our grid directly from game mode. But it spawns 6 tiles, not 5 as we set. This is because we count from 1, while the computer starts counting from 0. We can deduct 1 from our grid size, and this will make last index to be 4 and not 5. Now let's make grid also spawn up the z-axis. We need to add one more for loop for that. Last index will be same as first for loop. This time, we will be adding the multiplication of the second for loop index by our set distance to the z-vector. And here we have our gloriously standing tile grid right in front of us. Let's add a modification to set the starting height of the grid from the ground. Add to z-value. Promote the addition to a variable and name it grid height. Also add this as input value in our spawn tile grid event. Now, we can also be able to modify grid height from the ground. This is our gameplay level, right? So if we want to be able to click on tiles, we need to start modifying our game further. Let's add a pawn class to our gameplay, and this pawn will be our default pawn for the level. For this pawn, we don't need a skeletal mesh. Just a spring arm and a camera will suffice. Set this pawn as our default pawn for this level. Now if we play, we will just be a camera observing the world. We can't click on anything because we don't have mouse controls. And who controls the pawn? That's right, our player controller. Drag from parent begin play pin and add set input mode game only node. For player controllers, set self. Add a set show mouse cursor node and set it to true. Now we need to add enhanced inputs for our pawn. Let's go to character to see how it's set there. Enhanced inputs allow us to set inputs that apply specifically to a character, weapon, and so on. So let's add enhanced inputs for our new pawn. But we will do it directly inside player controller as we will use adjusting this level. Add enhanced input local player subsystem and check if it's valid. Now drag from enhanced input and add mapping context. We now need to create new mapping for our player controller. Go to Inputs and add Input Mapping Context. Name it IMC_Tile Flipper Controls. We don't have input action to add, so let's make one. This is our tile character's inputs inherited from the third-person template. Let's create a tile flipper folder and a character folder to store the input actions separately. Now we create our input action for left-click key. Just add a trigger of type pressed. And add our newly created input action as mapping for our tile flipper controller. And set our mapping context inside the controller. The enhanced input system requires setup just to start using action keys, but it has its perks. Now add our action key to the graph. It's more overwhelming than the old key nodes. The old system had just pressed and release pins, but those are kind of deprecated. I would recommend sticking with enhanced inputs. So the game plan is that when we click the left mouse button and it hits a tile, we get the hit result and perform a color switch on our tile. For that, let's use get hit result under cursor by channel node. Set trace channel to be our camera. And break hit result. This is all possible hit results. We will be looking for the hit actor, as our tile is of the actor class. So then we left click and hit under cursor is actor. We want to trigger its event of flipping. My recording session got interrupted, so we'll continue in the next one. Like, subscribe, and if you're able, support me on Ko-Fi.